Hello everyone, my name is Durgesh Kulkarni with my teammates Abhijit Thorat and Diptam Paul. We are the students from MIT World Peace University. We are going to explain our final year BTech project, that is Indoor Air Quality Monitoring System. So before we start, we will just explain what are the components that we are using. So firstly, this is the NodeMCU we are using. So why we have used NodeMCU is it has a built-in features of Wi-Fi connectivity, and it is easily it can be easily connected towards the internet. Also it has an easily connected towards the cloud as well. So next we have been using sensors. So first sensor what we have been using is MQ2 sensor. So MQ2 sensor we are using for measuring the combustible steam, MQ7 for measuring CO, that is carbon monoxide, MQ3 we are using for measuring alcohol, MQ9 we are using for measuring LPGs, MQ135 we are using for measuring CO2. So these are the 5 main sensors that we are being using in this project. So next component we are using is ADS 1115. So ADS 1115, in a simple language we can say that it is an analog extender for NodeMCU. So problem with the NodeMCU is that it has only one analog pin. So to extend the analog pins towards NodeMCU, we have to use this analog extender which has 4 analog pins. As we are using 5 analog sensor, so that is the main reason we are using analog extender. So analog extender is connected to the NodeMCU. It will get input from all the sensor in analog form, and it will be converting to the digital and will be sending towards the NodeMCU. So moving towards, we will see now the connection.
So the input for our project is taken from sensor. So each sensor having 4 pins, that is VCC, ground, A0 and D0. VCC pin of every sensor is connected to 5 volt and ground is connected to ground. Our project wants the real-time input, that's why we will be using A0 pin. So the analog pin of MQ2, MQ7, MQ3 and MQ9 are connected to A0, A1, A2, A3 pin of ADS 1115 respectively. After that, the analog pin of MQ135 is connected to A0 pin of ESP8266 microcontroller. After that, the VDD pin of ADS 1115 is connected to VIN pin of ADS ESP8266. The operating voltage of the supply voltage of NodeMCU is 5 volt. That's why it will be give 5 volt to ADS 1115 analog extender. After that, the ground is connected to ground, and the SCL and SDA pin, that is I2C communication pins, are connected to D1 and D2 pin of ESP8266 respectively.
Okay, so when we got all the analog values from the analog sensors respectively, we are converting that analog values into the ppm values. We had calibrated all the values in our code itself. We had calibrated the values according to the data sheets present on the website of the particular sensor. So moving forward, we will move towards the simulation of our. So let's move towards the working of our project. So here we are throwing the gas on the particular sensor. So in first we will throw LPG gas on MQ9 sensor. We have used lighter which has LPG gas in it. In the side screen you can see that their LPG gas in ppm concentration is increasing. So that is because we are throwing the gas. Then moving towards the next gas sensor, MQ7. So here we are throwing CO to the MQ7 gas sensor. So here we have used a gas perfume so that it can sense the CO concentration in it. Then for MQ3 it requires alcohol, so we are using hand sanitizers which has 2% alcohol in it, so that at least some amount of alcohol can be traced. So moving towards the next part, that is the ThingSpeak cloud. We have integrated our project to a ThingSpeak cloud, so we will move towards towards that.
Let's see the ThingSpeak Cloud. So what is a ThingSpeak Cloud? ThingSpeak Cloud is a IoT cloud platform that is used for storing the sensor data on the cloud. It is compatible with development boards such as NodeMCU and Arduino. It can be used for storing the data, analyzing the data, and visual representation of stored data. For precise calculation of air quality index, we have used the data stored of 70 days. So here the 6 field charts are there. 5 field charts are of MQ series gas sensor. Each sensor is dedicated for particular gas, and 6 one is of AQI. and the x-axis is a time period and y-axis is a gas concentration in ppm. So here you can see the sudden spike is there. This spike is because whenever we spread the gas on the sensor from close vicinity, then this spike will occur. And here is a linear because this is a gas concentration in ambient conditions. By taking the gas concentration of all 5 sensors, we have calculated the air quality index. Whenever the gas concentration of all sensors will increase, then the AQI will increase. From here, we can conclude that the relationship between air quality index and gas concentration is linear.
So let's move toward the next part. We have integrated our project to a web page, or you can say a web server. On the left hand side you can see the AQI is 46 and the status is good and the background is green. So it says that your home indoor air quality is good, and this color code was given by Ministry of Pollution Control itself. So likewise you can see all the color codes that were given by Ministry of Pollution Control, and whenever the AQI gets onto that range, the color of the web page will get automatically changed and user will get to know that what kind of AQI it is present in its home.
We have integrated a system with Blink app which will act as a user interface for the project. Blink app is basically a software which is used for mobile application development. It is simple to use and it maintains stable connectivity between the microcontroller for fetching real-time values. Now I am going to demonstrate a demo on the created Blink app interface for our project. So this is the Blink app interface that is visible on your screen. These are the different real-time gas concentrations in ppm. They are nothing but carbon dioxide, carbon monoxide, LPG, combustible steam and alcohol, and below you can see the AQI value displayed. So you can notice that there are high fluctuations in the values of the gas concentrations. This is because we are throwing continuous gases on the sensors so as to check the AQI range. But in ambient temperature, the value will lie between 35 to 45 ppm. We have also included a feature for alerting the user for LPG outbreak. Therefore, when the system crosses the desired threshold of LPG, the user will be alerted via mail and the ppm values will also be sent via mail. So basically Blink app is useful in creating different interactive user interfaces which is simple to use, and it helps in understanding the project in a proper manner. At the end, we would like to conclude that the calibration of the sensors is the most important part. Therefore, the sensor should be calibrated according to the datasheet of a particular gas, considering ideal atmospheric conditions. Error of the MQ sensors is very high, so to minimize the error, we can use PMS 5003. It will measure PM 2.5 and PM 10, which is recommended by Ministry of Pollution Control India. Thank you.